Hello, my name is Martin Beisse from EIS at University of Stuttgart. In this video, I'll showcase the prototype for the paper Observability for Quantum Workflows in Heterogeneous Multi-Cloud Environments. We start off in a workflow modeler and open the prepared workflow. The workflow implements the variational quantum algorithm Guava, solving the maximum cut problem using quantum modeling constructs. It comprises tasks for generating the circuit, selecting a suitable quantum device, executing the circuit, evaluating the circuit execution results, and optimizing the circuit parameters. As quantum workflows can benefit from on-demand deployments, for this use case we deploy all required services on demand using incomplete deployment models that we complete during runtime based on the requirements. These requirements can be specified using policies. For example, the circuit is generated in a public cloud, whereas the confidential data resulting from the circuit execution shall be evaluated in a private cloud. As our workflow is already modeled, we continue with the transformation of the quantum-specific modeling constructs to native BPMN modeling constructs. Hence, we click on Transform. Next, we need to prepare the workflow for deployment. Thus, we click on OpenTosca and then select Service Deployment. As we can see, our workflow contains deployment models that require completion and that are deployed on demand. Hence, we need to click on Upload CSRs. As you can see, our workflow comprises incomplete deployment models. Hence, users must enter their personal information for the cloud services they want to use. Once information for all node types that shall be used is given, we continue and click on Transform Workflow to include all the subprocesses handling the on-demand deployment. As you can see, our service tasks are transformed into subprocesses, which include the workflow for deploying the service and invoking it. Now we can continue to deploy our workflow to the workflow engine by clicking on Deploy Workflow. As you can see, the workflow was successfully deployed, and now we can continue to command that. Now that we uploaded the workflow, we first need to enter our credentials. Then click on Task List. Start the process that we just uploaded. Now we need to fill the form. Once the form is filled, we scroll down and click on Start. Now we can see that the process has been started, and we can switch to the Commander cockpit. Here we select our process. As we can see, we are currently in the subprocess for deploying the circuit generation service. Hence, we can click into the process and see that our completion resulted in this deployment model, which uses, as we wanted, a public cloud, and here we use an EC2 instance. We can also, since we're in the deployment view now, switch to the default view. We can hop into the subprocess and can see that we are currently uploading to the OpenTosca container. We can also observe that by going to the container and checking, okay, what's here. As we see, there's one application here, which is currently being created. As we now can see, the circuit generation finished, and we selected a suitable device for the execution of the circuit. Thus, currently the fragment containing the service for executing the circuit is deployed and then invoked. If we now take a look into the quantum view of the process, you can see the original workflow and also get information about the circuit that was generated. Here we see that the circuit uses 6 qubits and has a depth of 12. Further, we can see, compiled from the circuit data, what the circuit actually looks like. Also, if we hover over the circuit execution task, we can see that the quantum simulator was selected to avoid queuing times for this example. Now that the service for executing the quantum service was deployed and the service was invoked, we can get an overview of the probability distribution by hovering over the task again. Once the service for evaluating the circuit execution results has been deployed, we can also in the quantum view observe the results we retrieved. Here we can see an overview of the graph which was input to the workflow and compiled into a visual representation, also containing information about the edge weights and the connections between each of the nodes. Further, we can see the objective value resulting from circuit execution. Also, we can see that we have now 4 services that have been deployed, and one of them is currently still being created, which is the optimization service. To get an overview of the current deployment status, we can switch back to the deployment view. And we see the 2 topologies created for the circuit generation service and the circuit evaluation service. We see that the first deployment topology was indeed completed for a public cloud using EC2. The second one was completed using a private cloud utilizing an OpenStack instance. We can also observe the current usage of the VMs by hovering over the corresponding node type. As you can see here, we see the CPU usage, clock speed, RAM usage, and disk speed. As we can see, now that all services have been deployed, they are reusing the existing instances for the next iterations of the algorithm. Now that several iterations of the algorithms have passed, we can observe the current state, for example, of the optimization process. Here we see that 4 iterations have passed and the algorithm started in the center at like a value of 1 for parameter 1 and also 1 for parameter 2, and then checked first to the right, then to the top, then to the bottom left. Also, the objective value during these iterations was not better than the one of the initial execution. We now fast forward to a couple iterations later and see that during the next iterations a new optimum has been found at iteration 7. Now, as we can see on the left-hand side, the optimizer is searching around this area to find an even better value. Now that the process has finished, as we can see by the token reaching the analyze result task, we can have another look at the optimization history. Here we see that at iteration 22, a new optimum, in that case a minimum, has been found. Also, we can see in the graphic on the left that the minimum is around the area of the previously found minimum at iteration 7. Further, we can evaluate the final result, which is shown by this graphic. And we see that the objective value of minus 5.465 was reached. This concludes this demonstration video. Thanks a lot for your interest in our research.